Okay, and this is our second workshop problem. This is very similar to the last one, except we have a gap. And so we have to account for the gap, and we can do it much in the same way as the last problem that we did. And I'm not going to work through exactly how to get all the internal forces and whatnot, because that was done in the last problem. And you can probably work through and see how to do that. But what I want to do is I want to discuss how we can take care of this gap and how things are different. So if you go to workshop problem 1, and once again, we'll do this with the method of superposition. And so superposition says that we're going to assume that we get to this state B here, where everything is going to be touching. And so once we do that, this is where we have our 600 kilonewtons, our 300 kilonewtons, our FA, and our FB. Now, at this point, I should point out that this is where you should stop and give this a try. The big thing here is we have a gap now instead of 0, and we have to handle that, remember. So instead of having a deflection of 0, there is going to be some deflection we take care of. So give this one a try, come back, and I will start the solution for you to check to see where you're going. And so I will start the solution in 3, 2, 1. Okay, I'm assuming that you all went and gave this a try, and hopefully it was a little bit easier because you've already done the other workshop problem, and so we can take some stuff from that. Most specifically from the last problem, we got down to, okay, the deflection is the deflection from the load plus the deflection from that force that we put at B. Now, in the last problem, in workshop 1, we said, well, that's equal to 0. Because we had to push back on the bottom of it enough to take care of just what was deflected, because there was a solid wall there, and it couldn't deflect at all. This one's a little bit different, though, because we do have this gap there. So we are allowed a little bit of deflection. So the deflection is not going to be, we're not going to use that reaction force at B that we push back on everything to get rid of all of the deflection, because that's not what's going on. It is allowed to deflect by 4.5 millimeters before it hits the wall. So we're basically going to solve the exact same thing, but we're going to solve it with this equation here, where we will allow 4.5 millimeters of deflection, which will obviously change the amount of reaction force. So once again, if I go to the last problem, I had the deflection from the load when I removed the redundant force at B. We had found that was 1.125 times 10 to the 9th divided by E. And we found our deflection from point B, from that force at B, was negative 1.95 E to the 3rd times that force at B, that reaction force, divided by E. Now, we know E now, so we can plug that in. And so this time, instead of saying delta P plus delta B is 0, we're going to say that that's times 4.5 times 10 to the negative 3 meters. That's 4.5 millimeters. I just made the conversion. So 1.125 e to the 9th. I'm going to divide that by 200 e to the 9th, and that is our pascals. We're going to take away from that 1.95 e to the 3 force of B divided by, once again, 200 e to the 9 pascals. And we have to have that in there now, because since I have that 4.5 millimeters on the other side, when I multiply through, things aren't going to be 0. They're not going to go away. And so once again, now I'm at a point where I've got one equation, one unknown. And so I can sit there and go, okay, the force in B is going to be what? Well, it's 115.4 kilonewtons. Now, it's much smaller than what it was in the first problem that we did, because it allows it to grow a little bit before it starts pushing back. And so how do we find FA? Once again, we go back to that very initial statically indeterminate equation that we had. where the force in A plus the force in B was going to be 900 kilonewtons. And so you just plug in that 115 into there, and then you go, okay, well, the force of A works out to be 785 kilonewtons. So now that we've allowed it to grow in that gap, we have much more force that's being applied into that statically indeterminate beam. Oh. Now, once again, this is getting a little ahead of myself here. This is fundamentally the same problem as Workshop 1, but the only difference is allowing that gap to grow. And so I hope you were able to go through both of these and not really have any problems. Like I said, the second one is fundamentally the first one, just changing a little bit of how it can grow.